All right, everyone. So we have a really exciting course coming up in spring, and that's called TinyML or Tiny Machine Learning. And so you might be, obviously familiar with a lot of machine learning that's happening in everyday life, right? So I mean, you take a picture with your phone, it's using machine learning to really enhance the picture, right? And then after that, it's you look at image classification. Is it a cat or a dog? That's using different types of machine learning algorithms. And this has become so routine now that, or you want to do object detection and you want to count the number of objects. You can do all of this so automatically, and you can view all of this so easily in your with any of your your smartphone, and including like really exciting applications like self-driving cars. They're using like what is called video segmentation. They know what is the drivable surface, what's this, where are people, where are other objects, where's the sidewalk, and that gives them a lot of information on how to think and live within our world. And finally, there's machine translation that's happening in real time. You speak in English or in language one, and it automatically translates it into another language. All of this is largely working on in large data centers. And maybe some of it is working on in your phone. And what we are interested in this course is to teach you how to bring parts and the exciting parts of these applications to run on a small, tiny, less than $1 embedded microcontrollers that you can actually program, and you don't need a data center to do that. And so this will actually blow up the whole use of machine learning, like from machine learning in your mouth with smart toothbrushes, machine learning in your home with smart thermostats, machine learning in your ears with, and so on, right? So we're really bringing machine learning to the edge, to these endpoint devices, and we'll teach you about how you can actually build these applications on your own. And so what this course is about, well, first, you can think of this course as your first course in machine learning. You've never done machine learning before. You think it's cool. You've dabbled a little bit with machine learning. We'll introduce you from zero to hero over here. And then you can also think of this as your first course on embedded systems, where you actually get machine learning to be programmed in tiny little battery-powered embedded devices. And this practically requires no prerequisites. I'll get into that a little bit more. But basically, if you're a freshman or a sophomore, definitely you're totally fine with this. Any major is totally fine. And most importantly, it's a lot of fun because you get to actually work hands-on, and you're making these applications, live throughout the course. And also, it's not a terribly hard course. We're not trying to make it like so onerous. We want you to actually learn and enjoy learning together. And so essentially we will each person in this course will get a kit, and essentially that's in a little tiny box like this one over here, and you get to program a tiny microcontroller. And this course is over multiple stages, and you learn a lot of the foundations of machine learning. But this is really focused on not the theory of machine learning, but on building really cool, awesome applications that you can then take forward after you learn from this course. And so the application number one is on keyword spotting. That's like when you say, hey, Siri, or you're saying something like, Alexa, turn off dim the lights. So how does this little embedded device actually understand this wake word, this keyword like Alexa or Siri or OK Google, and how do you actually get to program that with your own custom wake keywords on your own hardware, like that, right? A second application is using the camera. So this platform also comes with a little camera board that sticks onto it, and you'll use that camera to actually detect whether there's a person or not, or whether a person's wearing a face mask or not, and you will build these machine learning pipelines from scratch. Is that right? You learn how to do that. And the third application is anomaly detection, like detecting a fall or anything that you cannot train for in advance. Most of machine learning is saying that I've trained on a lot of data, find these patterns. And over here, we're saying, look, we don't know what we are looking for. It's a rare event. How do you find rare events? How do you actually succeed in doing that, like that, right? So And so that's but with each one of these, you'll be using multiple sensors. So say, for example, in this anomaly detection, you'll be trying to look at time series sensors. In other cases, you'll be looking at image sensors or audio sensor inputs. And so everyone will get this hardware kit. And actually just today, I just came from the lecture now, we distributed all the kits to everyone. And so they've got it running on with their laptops. And this kit is really, really extensible and versatile. It allows you to do very interesting projects later on. And once you finish this course, maybe for senior design, you want to do other, tiny machine learning projects, you can take it all the way forward. So the course is broken into 3 parts. There's the fundamentals of TinyML. We teach you like what is the machine learning language and the workflow of building a machine learning pipeline. And it's very different from explicit programming. In part 2, you actually build these 3 applications and you get to run them. You build the neural networks end to end. And in part 3, you actually get to put that on hardware and you learn about all the constraints of shrinking these large models into tiny models that can fit on less than 256 kilobytes of RAM. And so we take you through this whole pipeline. We teach you TensorFlow basics, where you can train the model, and then you learn TensorFlow Lite, which basically converts a large model and shrinks it down with different techniques to actually compress these models down. And then you actually start to interface with all of these different sensor types, and you optimize your network and figure out how do you get the best performance out of this network. So it's got to be good, fast, and cheap, right? And we want to try to optimize for all of those 3. And so essentially, you can think of the first application is like this is keyword spotting. So you say, okay, Google, and then it has to wake up the phone, and then it has to answer to you. And so what you learn over here is when you're building this keyword spotting applications, you learn about how do you do build Cascade machine learning architectures for these edge devices. So how can you have a really, really cheap, tiny microcontroller that starts to detect whether the keyword is made? It wakes up a bigger processor, and then it goes to the cloud and wakes up the cloud. And so how does this actually work on your phone? And you'll actually learn how to do that, all the way from scratch on your own. And we'll take you through the signal processing stages. And all of this is done through Colab. So you have like ready-made Colabs and tutorials to walk you through this. How do you get the raw audio signals? How do you do the FFTs? How do you then do a lot of different processing stages so that the signal is now ready to be put into a neural network? You can't just put a raw audio signal into a neural network. In fact, we convert this into an image, and then we input the image into a neural network. And then we learn about things called transfer learning, where you can reuse someone's pre-trained model. Maybe they spent like several $1 million coming up with this really good model, and then you reuse it. But for your application, you take most of their model and you just add your part to it for task-specific aspects, and you learn how to do transfer learning also. And finally, you also learn about autoencoders, and this is for anomaly detection. You learn how to compress a lot of like high-dimensional data into just the real intelligent nuggets of that data, and then decompress it to basically capture, an image of the same replica of that. And then we'll show you how you can creatively use this to find rare anomalous signals. And so this is a very interesting technique. And all of this is like post, 2017, all of this machine learning stuff, but we've distilled it to make it easy enough and to make it applicable over here so that you can actually run it on these hardware platforms. And so we'll take you through this entire life cycle of machine learning. It's not just about making a machine learning model, but you'll understand about how do you do data collection, ingestion, labeling, and essentially do the whole machine learning pipeline. And that'll help you also get a really good summer internship in one of these hot FANG companies. So this I've put as, the first section is on the fundamentals of TinyML. And we'll walk you through building a neural network from just one neuron to multiple layers to more complex neurons that can then do, like, say, computer vision. And we'll talk to you about, using convolutional neural networks. Then in part 2, you'll actually work with different applications, like I mentioned. And so you'll learn how to actually build these keyword spotting, wake words, anomaly detection, and actually even learn to architect. For each of these applications, we'll walk you through how do you get the data, how do you process the data so that it can actually be input in the neural network. Now you have a big fat neural network. How do you shrink that down And then how do you actually evaluate whether it's actually working well? And finally, in part 3, you'll actually get to do this even on a little robot platform, and you'll actually work with actual hardware. And we'll also have some guest lectures from people who are really doing cutting edge stuff, but on TinyML over here. So the course is really structured by where we have lectures that are in video and in person, and so it's mixed. And essentially, I'll be giving the videos and the lecture together. Then there are lots of very interesting readings that are there, because machine learning is a very hot topic, but we want to make sure that you get the good foundations, and we'll walk you through, and the readings are also very detailed, and they guide you through the whole process like this. And then there are many labs, right? So with every lecture, we also have a tutorial that is in, hands-on, and we'll share with you the collabs, and you actually will program along with us. So you make sure that you actually get that. And there are quizzes and tests. I don't like quiz exams, so we just have short quizzes throughout the semester. And also one really important aspect that we touched through in each one of these modules is, responsible AI. And how do you make sure that you have good frameworks for understanding, what is fair, what is ethical, how do you detect bias, and so on, right, in these machine learning models. And so the course is all listed out with, you can see that I think over 27 different tutorials through that, to make sure that you actually, follow through and build up both your skill set and understanding the TensorFlow API, and also in building up your conceptual knowledge of, different machine learning types and architectures. And then there are about, I think, 8 different assignments that will get you through that. But the tutorials help you with that. The readings help you with that. And so just, what do I need to know before this course? Just basic programming in Python, nothing exceptional. Some exposure to electronics and circuits, so any basic, like ESE 111, or even if you just had it as a hobbyist. This is going to be a hard course. Well, yes, because the material is hands-on, you have to actually be coding this, but we'll be walking you through all of that. And no, it won't take more than 10 hours per week. We want to make it light and fun, and will this get me an internship? Okay, I don't have all the answers, but I think you'll have a really good chance in doing that, right? We have really good TAs who are actually TAing this semester. They help build up the course. It's a brand new course. And that's me with my, I think, 15-year-old picture over there. I got married, but and you can come and talk to me. My office hours are on Fridays 2 to 3. And so I'm super excited about, bringing tiny machine learning, to Penn engineering. And because I really believe the future of machine learning is tiny and bright, because we now get to get machine learning right at the edge in billions of these devices. And we're also really excited to see what you can do building with this. All right, that's it.